What we're going to talk about next is a thing we like to call differential equations. And what separates differential equations from just regular equations is the fact that these equations will have, not only will they have a y and an x, but they'll also have the derivative of y. So a differential equation is an equation that relates y and one or more of its derivatives. For example, y prime equals xy. So yeah, we got y and x, but we also have involved in this equation y prime. So that's basically what a derivative consists of. You can have more than the first derivative. That's also a differential equation, and it involves y second derivative along with the first derivative and y itself. So yeah, things can get complicated if you really get into it. There's whole courses based on this topic, differential equations, but we're just going to briefly preview some of the ideas here of differential equations. First of all, just kind of a note, the differential equations are ranked, I guess you might say, by their order, call it order. And the order of a differential equation is just the highest derivative that is contained in the differential equation. So the order of a differential equation is just based upon its highest derivative, quote unquote highest derivative. So the first one I have here, we got y prime, so that's first order differential equation. And then so the second one I've got here listed, got a second derivative, first derivative. So that would be a second order differential equation. All right. Pretty simple idea there. That's how they do it. All right. The first thing let's just talk about is what it means to be a solution to a differential equation. Say, for example, 2y prime plus 3y equals e to the minus x. So there's another first order differential equation. Well, to be a solution, obviously, it's the same thing. We got to have the left side equals the right side, and so we need to come up with a function, y equals equation, such that if we plug in the y, that particular solution in for y, and then its derivative, it makes the equation work. Okay, it makes it a valid equation. So it's fairly simple. So a solution is it's just a function, y equals a function that satisfies just like you would think. Okay, so in this particular case, let's just check to see if or verify, you might say. What is it? Y equals e to the minus x plus e to the minus 3/2 x is a solution. We'll talk about how we might come across that, come up with that particular equation, but let's just verify or check it to see that it is a solution. And so all that means is check or verify just means plug in the y, in this case the y prime, and its derivative. See if it works. Okay. That's all we're going to do here. Now, we've got the y, so I'm going to plug that in. The y prime What do we got for y prime here? Okay, so it's just chain rule basically, I guess. The derivative of e to the minus x. Be e to the minus x times minus 1, right? Because that's the derivative of the power. And then this would be, derivative of that would be minus 3 halves e to the minus 3 halves x. Again, by the chain rule. E to the minus 3 halves x. E to the minus 3 halves x, and then minus 3 halves because that's by the chain rule, the derivative of the power. With me there? Okay. So, I just take these two and plug them in appropriately. This one goes here, and y prime goes here. So we just see, all right, so if I do that, 2 times the y prime, so it'll be minus e to the minus x, minus 3 halves e to the minus 3 halves x, plus 3 times that, e to the minus x, plus e to the minus 3 halves x. Does that indeed equal e to the minus x? So just kind of verifying. Basically what this will mean is just simplify right, the left side. Let's multiply here. We will have negative 2 e to the minus x. 2 times minus 3, so that would be minus 3 e to the minus 3 halves x, right? 2's would cancel those out. And then here distribute the 3, so that would be plus 3 e to the minus x. And then plus 3 times that, so it would be 3 times e to the minus 3 halves x. So is this going to work? Yeah, this has got to simplify a lot, doesn't it? It's got to equal e to the minus x. What happens? Ooh, look at that. You got a plus 3 e to the minus 3 halves x, you got a minus 3. Wipes out. And then, yeah, these two, they are like terms, if you will. You got a minus 2 e to the minus x. Hey, how about that? Minus 2 e to the minus x plus 3. That's e to the minus x, isn't it? So you got it checked out. So similar to the old geometry verifying your proofs or whatever. Okay. That's not sticking very well. Okay. Now, here's another thing on these solutions. Yeah, this is pretty specific. There's not any thing we could do to change that up. But a lot of times these solutions to differential equations come in as a family of functions. Here's, for example, for y prime equals 1/2 y squared minus 1, the solutions are, notice I said solutions, are y equals 1 plus c e to the x over 1 minus c e to the x. So the reason I say solutions there is notice I've got it, not only do I have the variable x, but I've also got c. What do you think that means? That's a constant, yeah. What this means is the solutions to this could be anything with that, that's the same c there, but any number c, replace that, and it's going to be a solution to the differential equation. In other words, 1 plus 5 e to the x over 1 minus 5 e to the x, that's one of the solutions. 1 plus 2 e to the x over 1 minus 2 e to the x, as long as those two numbers are the same, that's going to be a solution to this. So that's why, that opens it up to a lot of different equations. Just substitute different numbers there. Infinitely many, if you think about it, right? Well, yeah, so that's why they call this, if you got that sort of thing, that's a family of solutions, because you've got infinitely many solutions there, really. Now, I think what I was going to do just to do another one of these, verify them. Yeah, so let's verify that, that to be true. So same idea, plug in this for y and then its derivative for y prime and see if it works, okay? So again, when you're verifying these, of course, what you first need is, you need your first derivative. In this case, if it calls for the second derivative, you do the second derivative too. So what's my first derivative for these solutions, mainly solutions here? Well, that's a little complicated, but that's okay. It's quotient rule, isn't it? Low d high minus high d lower, favorite thing there. So 1 minus c to the x times the derivative of the top. And c is just a constant. 1's a constant, of course, so that's 0, but c is a constant, so that's just c to the x, isn't it? It's the derivative of that, top. Minus then high, 1 plus c e to the x, times the derivative of the low. Well, the low, derivative of that's 0, and the derivative of that, derivative of e to the x is e to the x, so it's just minus c e to the x. And all that rho squared. Looks pretty complicated, but I think, if I remember right, these kind of simplify here. If I go ahead and distribute here this out, get the derivative is c e to the x minus, all right, now when I multiply these two together, what happens there? Well, you got c times c, so you got c squared, and then e to the x times e to the x. You add the powers, you got e to the 2x. So it's c squared e to the 2x. That. Pretty much the same thing happens here. Distribute that, and so that'll be minus c e to the x minus c squared e to the 2x. But it's minus that, so we wind up with plus c e to the x plus c squared e to the 2x. It's minus that. This is about, yeah. No, I won't say this is the hardest part of this, but oh, look at that. C squared e to the 2x, you got a minus 1, you got a plus 1. Now these, you got c e to the x, c to the x, so that's 2c e to the x's, right? Okay, so I think I'm done there. Question?
Minus on the bottom.
Oh yeah, thank you. 1 minus c e to the x, yeah, because it's low squared. Low squared, yeah, thank you. Just checking. Okay. So, that's my y prime, that's my y. Let's plug those in. So this goes in for y, and this goes in for y prime. So we've got 2c e to the x over 1 minus c e to the x squared. Does that indeed equal 1/2 times y squared? So it'd be 1 plus c e to the x over 1 minus c e to the x squared. So yeah, that y, I've got a square, and then subtract 1. Let's work on this side first. So we got 1/2, not much we can do here. We got 1/2, 1 plus c e to the x, that would be squared, and then 1 minus c e to the x, that's squared minus 1. guess there's different ways of doing it. One way to do it is just go ahead and combine these into one fraction, get a common denominator. Of course, it would just be multiply this by 1 minus c to the x squared, right? Top and bottom. So that would be 1/2. Then I have common denominator, so it's 1 plus c e to the x squared minus 1 times 1 minus c e to the x squared over, then I've got a common denominator. So well, we've got sort of looking like, because I got the denominator right, but yeah, just a matter of squaring those out. See what we get here. Those out. So 1 plus c e to the x times 1 plus c e to the x. Squaring that out. What is that? 1 plus c e to the x plus c to the x times 1 c e to the x, and then c squared e to the 2x. And that's 2c e to the x. So I've got 1 plus 2c e to the x plus c squared e to the 2x. All right, then I've got minus 1 minus c e to the x squared. Well, that's a similar deal, but let's see what we get there. 1 minus c e to the x minus c e to the x plus c squared e to the 2x. Got 1 minus 2c e to the x plus c squared e to 2x. Yeah. And that's behind my minus there, so it's 1 minus 2c e to the x plus c squared e to 2x. Well, I think nice things are going to happen, aren't they? Because yeah, so let's just do it here. That would become minus 1, that would become plus, and that would become minus. So yeah, the ones are going to cancel. The c squared 2x's, either 2x's are going to cancel, but the 2c e to the x, I've got 2c e to the x and 2c e to the x. So I've got 4c e to the x. I believe so. We're almost there, because now 2 goes into that 4, so I wind up with 2c e to the 2x over 1 minus c e to the x squared. Is that what I started with, or what the left side is? Yes. Check, check. Okay. It did check out. Any questions on that? Is that okay? Any problems or concerns here? Good? All right. So, one other part here, this first part anyway. There's a thing they call the initial condition. I think I'm going to use the same one, but So the solutions here, what was it? Y prime equals 1/2 y squared minus 1. That was my differential equation. And so the solutions are y equals 1 plus c e to the x, 1 minus c e to the x, yeah. Okay. Well, there's this thing they call the initial condition that sometimes they would give us. And what the initial condition is it gives me another piece of information. And with that piece of information, what I can do, remember we said this is infinitely many solutions here. With that initial condition, we can focus in on the one solution that fits that solution and then that initial condition. And so here's our first look at that. Okay, so find the solution from that family of solutions, right there. That has the initial value, initial condition, initial value, y of 0 equals 2. So we know these are the solutions, but we want to find the one that has this condition also. Y of 0 equals 2 is how they'll write it. I mean, it's a little bit of a funky way of writing it, but it's the very same idea. So what does this mean? Basically what this is getting at is I can find the C value that satisfies this, and then plug that C value in, and that's my specific solution that satisfies that has. I forgot the word there. All right. So you've already got your solutions. Now we just have to match, basically match these up. So what do we do? Well, it's like I said, it's kind of a different take. We usually don't do a y of 0. We usually do f of 0 or something like that. But it's the same idea. This is the input value, so that's the x value, and the 2 is the y value. So I'm just going to plug in those for y and x. It's all for c in my solutions here. So the 2 is the y. 1 plus c e. Oh, and they were nice because usually the initial value. So they're talking about the x is 0. Maybe not always, but and then so 1 minus c. Just make substitution. Y is 2, x is 0. That's all I did. Which does simplify, because e to the 0 is 1, so that top would just be 1 plus c times 1, so just 1 plus c. Same thing on the bottom, 1 minus c, right? And so now what they want us to do is just solve that for c. How would I solve that for c? I believe the first step I would take would be multiply both sides by 1 minus c. That would cancel 1 minus c over there. Denominator out. This side will just be 1 plus c. This side will be 2 minus 2c. However you want to. Let's add 2c and subtract 1. So we got 1 on this side equals 3c. So c is 1/3. And now that's not necessarily the answer they want. What they want is the solution from the families. So what they want you to do is go ahead and take that for C and plug it back in, that's the answer they want. So the answer they want is y equals 1 plus 1/3 e to the x over 1 minus 1/3 e to the x. Just plug that C value found back in. So it gives us just that specific solution. We now know what the C value is. It's not infinitely many, it's just 1/3 there. Question?